Hi, this is Leetcode question house rubber, and this is question 3 from weekly contest number 331. There are several consecutive houses along a street, each of which has some money inside. There is also rubber who wants to steal money from the homes, but he refuses to steal from adjacent homes. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. You are given an integer array nums representing how much money is stashed in each house. More formally, the ith house from the left has nums of $i. You are also given an integer k representing the minimum number of houses the robber will steal from. It is always possible to steal at least k houses. Return the minimum capability of the robber out of the possible way to steal at least k houses. Now in this example here we have 4 houses, and notice that we cannot steal 2 adjacent homes, so the robber cannot steal 2 and 3 because they are adjacent. He can steal 2 and 5, which is the first house and the third house, and the capability will be 5, which is the maximum of these 2 numbers. Another choice is steal the first house and the last house. The capability is the maximum, which is 9. Another choice is to steal the second house and the last house, and the capability is 9. Now the minimum capability of all possible ways, so we have 5 and 9, and the minimum is 5, and so the output for this example is 5. For this example we can steal the first house and the last house 1, and the maximum of this is 2, and this is the minimum value we can get if you try all the option, and this is the answer. Now how can we solve this efficiently? What we need to do is to do binary search of values between 1 and 10 to the power 9, which is the maximum. So we set the left to 1 and the right to 10 to the power 9 plus 1, and we do binary search between these value, and for every value we need to search for every value we get if we can find, or how many houses we can steal, given that the max is m is the number we get from binary search, and initially m is the middle, so 1 plus 10 to the power 9 divided by 2. So in every iteration we look for the middle, and for this value we assume it's the answer, and we need to iterate and see how many houses we can get if this is the max value, and if the number of houses we get is greater than or equal to k, then this is a possible solution, and we set our answer to this value, and we keep looking for a smaller answer. So for every middle, assume we have this array 1, 2 5 4 7 8 3, and let's say L equal 1 and R equal 10, and we have K equal 3. So we start iteration by M equal 1 plus 10 divided by 2, and this equal 5. Now we need to see how many houses we can steal such that the cost of the house or the house contain money less than or equal to 5. So this is less than equal this is less than 5. So if we have count which is initially 0, so 1 is less than 5, we increase it by 1. Then we cannot steal this one because it's adjacent to the first house. Then we need to move to the next one, and this is what we are doing here. So we increase the count and we do plus I. Then 5 is less than or equal to 5, so increase the counter to 2, and we cannot steal this because it's adjacent to this, so we need to check this one. 7 is greater than 5, 8 is greater than 5, 3 is less than 5, so we increase the counter to 3, and that means we can steal 3 houses if the max value is 5. So we set our answer to 5. Now we need to see if we can get minimum or better answer than 5. So what we will do, we set the right to the middle and left stay. So we have 1 plus 5 divided by 2, which equal 3. So assuming the max money amount is 3, how many houses we can steal? Start from this one. 1 is less than 3, so the count is 0. We increase it to 1. Then we need to check for this one. 5 is greater than 3, then 4 is greater than 3, 7 is greater 8, and we have 3, so we increase it to 2, and notice that 2 is less than K, which is a 3, and that means the value 3 is not possible solution. We need to find we need to check for values between 3 and the last solution, which was 5. So 3 plus 5 divided by 2 is 4. Now again we need to check for 4. Notice that while iterating to see how many houses we can steal, so when we said we have the value 5, so 1 is less than 5, and we steal this house. Notice that you can say that why not we steal this one, then this one, like this, instead of stealing these 2 houses here. And the answer is, if you steal this house, then you cannot steal this 5, then you need to steal this 4. But if you steal this one here, also you can go directly and steal this one, which is 4, and that means starting at the first element you can cover all or you will have the best answer, and this is why we check the first element always. And the time complexity for this is big O of 10 to the power log of 10 to the power 9 multiplied by n, which is the length of the array,